The graph of a quadratic function with vertex negative 4, 2 is shown in the figure below. Find the range and the domain. So the vertex is negative 4, 2. The part that's important is the 2. Because for all quadratic functions, all parabolas, all quadratics, the domain is always going to be negative infinity to infinity. It says write your answers as inequalities. So here we would choose all reals. All reals. Domain is all reals. Now the range is going to depend on if it opens up or if it opens down. If it opens down, you'll notice the y values are going down. The y values are less than this 2. So the range is going to be y is less than or equal to 2. It could be equal to 2, but it's less than or equal to 2. So that's how you write it when it says as an inequality. So if I had a parabola that was like this, and I had the vertex 3, 4, the range would be y is greater than or equal to 4 because it's going up, and the domain is all reals. Find the range of the quadratic function. First thing we notice is that this is a parabola that opens up because it's positive. And so our range is going to go from some point to infinity. So that's opens up. Your range will look like that. If your parabola opens down, which this one does not, if it opened down, your range would look like negative infinity to some point, and that point is going to be the point that's your vertex. So you have to find your vertex. So to find the vertex, x equals minus b over 2a. Here x would be minus negative 20 over 2 times 2, or positive 20 over 4, which is 5. That's the x-coordinate of our vertex. The y-coordinate, I plug that in. A is 2, B is negative 20, C is 52. So it's ax squared plus bx plus c. So A was 2, and x is 5. 2 times 5 squared plus b is negative 20 times 5 plus c is 52. So that's 2 times 25, that's 50 minus 100 plus 52 is 2. So our y coordinate of the vertex is 2, so our vertex is 5, 2. It's a parabola that opens up, so that means when it opens up, it is 2 to infinity. So just remember, up, the range will be a number to infinity, and that's the y coordinate of the vertex. And if it opens down, it would be negative infinity to the y coordinate of the vertex. Okay, so we've got several kinds of functions here. Here's what you want to look for. So if we've got f of x equals a number, just a plain number, then that is a horizontal line. If you have x equals a number, that's a vertical line. If you have a number times x plus or minus a number, and that's optional, you don't even have to have that. And if this is positive, then you have a line with a positive slope. So that would be, examples of that would be three x minus 2, 1/2 x plus 1, 6x minus 6, x, 5x. All of these have just an x, and the x is positive. They don't have an x squared. They might or might not have a number. Those will be lines with a positive slope. So f of x equals those. Those are lines with a positive slope. If it's just a number, if I had f of x equals 3, that's a horizontal line. Or f of x equals 0. Or f of x equals -1/2. Those are just numbers. Those are horizontal lines. Vertical lines, x equals 2, x equals -6. If I have ax plus or minus b, where this number is negative, then I have a line with a negative slope. So -1/2 x, that's a line with a negative slope. -12x minus 6. -6x plus 3. What's important is this number in front of the x. If that's negative, it's a line with a negative slope. Then I have things that have something squared in it. Doesn't matter what else it has, but if it has a squared in it, what matters is the number in front of the squared term. So if the number in front of the squared term is positive, so positive 5x squared, that's a parabola opening up. So I could have 5x squared, I could have 1x squared minus 2x minus 200. I could have 3x squared plus x. I could have 6x squared minus 5. The thing that's important is the x squared and the positive. That makes it a parabola going up. And if I have an x squared with a negative, that makes it a parabola opening down. So how do you tell what it is? There's what you look for. Does it have an x? If there's no x, just a number, it's a horizontal line. If there's an x, no x squared, then if it's positive, it slopes up, negative slopes down. Doesn't matter if it has a number. If it has an x and no x squared. If it has an x squared, doesn't matter if it has an x or a number. If the x squared is positive, it's a parabola opening up. And if the x squared is negative, it's a parabola opening down. So let's check what we've got. F of x equals 4. That's just a number. That is a horizontal line. Negative 2x plus 2. It's got an x. Does not have an x squared. It's negative. That's a line with a negative slope. It's got an x squared. That's negative. That's a parabola opening down. One more, and then I have to go from here, and I will come back later. Okay, for each coefficient, determine whether it's positive or negative. So if it opens up, it's positive, and if it opens down, it's negative. So that is easy to tell. So we've got this opens up, so positive, positive, negative, negative. Choose the coefficient closest to 0. Closest to 0 is the widest. Greatest value is the narrowest. Narrowest, it says greatest value, and so I guess we need to take into account whether it's positive or negative. So the narrowest positive. If it said least value, we would want the narrowest negative. Okay, so A is positive, B is positive, C is negative, D is negative. Closest to 0 will be the widest. It looks like A to me. The greatest value will be the narrowest positive, so that would be B. If they asked for the least value, that would be the narrowest negative, and that would be